Good day or welcome once again. In our last class, we learned how to derive the formula for calculating the area of a segment. Okay, and I brought upon myself to do another video where we'll be applying that very formula we derived to calculating the area of the what a segment. Okay, so because we derived that, we are familiar with the formula. Okay, now looking at this shape here, this shape is deduced from a what? From a circle. And this is what I'm implying by that. So if this is a circle and this is the center of the circle, okay, a line drawn from here to here is a radius, which you can see here as what? 10 centimeter. Then another line drawn here again is another radius. So we have two way diagram, which is 10 centimeter on both sides. Okay, so 10 centimeter. Then the angle at the center here is what? 63 degree. Then if you notice the distance from here to this point, let me draw this in the way that okay, the distance from here to this point, you have a line that demarcates here like this. Okay. I know that this place is what? Is curved. This place is curved. Okay. So this place is curved. That is where we derive this from. Okay. So that means that this very portion we are looking at now is a segment. Okay. So to find the area of the segment, just like I pointed out the other time, that we need to consider the total area of this shape, which is area of a sector. Then we subtract the area of this considered part, which is the area of a triangle. When we subtract that, we get the area of this side too. Say that area of segment is equals to area of sector, which is theta over 360 times pi what? R squared. Okay. Minus area of a triangle, which we term as what? Half r squared sine what theta. Okay, half r squared sine what theta. So from this very question now, have that our theta is 63 what degree. Okay, our pi, we can take pi to be 22 over 7. All together. Then our r is what? 10 centimeter. So substituting this very place. Okay, we are going to have our theta as well 63 degree all over 360. Our pi is 22 over 7, and our radius is what? 10 centimeter. Then all what? Squared minus 1 over 2 into our radius is 10 centimeter all squared. Then times the sine of the angle 63 degree we are doing there. Okay, so we can go ahead to multiply everything we have here out to arrive at our final answer. So how do you go about that? The square of 10 centimeter gives us 100 centimeter squared. Okay, that 100 centimeter multiplied by 22 gives us 2,200. Then multiplying that times 200 by 63, that gives us 138,600 centimeter squared. All over 360 times 7 gives us 2,520. Okay, minus then taking the product of 10 centimeter squared, that gives us 100 centimeter right squared. So I'm going to have 100 centimeter squared times what is the sine of 63? Checking that in our calculator, sine 63, we have that as 0.8910. That is approximating to 4 decimal place. We have 0.8910. Okay, then everything all over what? 2. Okay, now our aim now is to divide this by what? This we have 138,600 divided by 22,520. So that will give us 55 centimeter squared. Okay, now we are going to take the product of this. 100 multiplies 0.8910, that will give us 89.10, right? So that 89 that we have there, 0.10 divided by 2, we are going to be having that as what? 44.55 centimeter squared, right? Because everything here is supposed to be centimeter squared. It's area of the very what? Triangle we are considering. Okay. So what do we do by subtracting this from 55? So if you subtract it from 55, Subtracting 44.55 from 55, I'm going to be having this as well, 10.45 centimeter what squared. Okay, and that is the area of this seeded what part known as the segment. Okay, thank you so much for joining us. We'd love to see you in our next class. So do have a blessed day.